So, originally, the DICOM SOP Classes PowerPoint and lecture was 35 slides and about 40 minutes long, and I wouldn't subject you to a 40-minute video of me droning on about DICOM SOP classes, so I have split it up into 4 PowerPoints, and we'll try to keep it down to about 5 minutes. But you'll notice on the knowledge checks for this week that the knowledge checks are just SOP Class 1 and SOP Class Continued, so the knowledge checks don't match one-to-one to the different PowerPoints because I just split the knowledge checks in 2 and I split the PowerPoints into 4. Okay, so enough of that nonsense. Let's talk about SOP classes. SOP stands for Service Object Pair. It is the union of a DICOM object and a DICOM service. You can express many things you do in your daily life as a SOP class by combining the object involved with the action taken. Did you start your morning with a cup of coffee? That's the SOP class Coffee Get. It's a combination of the composite service CGET and the object involved coffee. And it's usually written with the object first and the service last. In fact, I'm going to give you a chance to make up your own SOP classes in the worksheet this week. I'm going to give you the service, and you are going to use the object to just make up your own SOP classes. That's your worksheet for this week. You will use a C service and put your own object with it. Okay, now you try one. The object is a CT image. The service is store. What's the SOP class? It's CT image store. So, how many SOP classes are there? Well, there's a lot, and they change. New ones get added, and older ones get retired. And in the back of your DICOM book, Appendix A3, it lists 187 SOP classes and their UIDs. Basically, each DICOM function an application entity can do is a separate SOP class, and each SOP class has its own UID. Remember, UIDs are how application entities determine what functions they can do. In other words, if a scanner said, Tom, are you a 1.2.840.10,008.5.1.4.1.1.2 SCP? What do you think the scanner just asked me? The CT scanner just asked me if I can do CT image store, to which I would reply, no, I'm not an SCP for CT image store. Go away, you silly DICOM machine. Storage SOP class. The storage SOP class is the DICOM data workhorse, responsible for moving DICOM images and other data between AEs. Think about what a PACS system's primary function is. Its primary function is to store images. CT images, ultrasound images, nuke med images, MRI images, every kind of image taken gets stored in the PACS system. That's why the storage SOP class is the data workhorse. The storage SOP classes are made up of the data that needs to be stored and the composite service C-STORE. Examples of storage SOP classes from your book would be X-ray angio image store, positron emission tomography image store, CT image store, enhanced CT image store, nuclear medicine image store, ultrasound multiframe image store that's been retired, the new ultrasound multiframe image storage, MR image storage, enhanced MR image storage, and the list goes on and on. Storage isn't just for images. Secondary capture image storage, that's something, let's say secondary capture. It's not the primary image acquisition, it's something that's been scanned in like a document. 12-lead EKG, ECG, electrocardiogram waveform storage, general electrocardiogram waveform storage, basic voice audio waveform storage. You can store voice clips in PACS. Hanging protocol storage. It's how you would store a hanging protocol for a particular user. All of these are stored in PACS, not just images, other things related to images. The storage SOP class. Another way to describe the storage SOP class is that it is made up of the C-STORE IOD and the C-STORE DIMSE. The C-STORE IOD is the data to be stored, the CT image, the CR image, ultrasound image, and the C-STORE DIMSE, the C-STORE service. C-STORE takes care of instructing the image accepting AE on what needs to be done. It uses the standard DICOM request and response messages. In other words, the CT scanner would send a C-STORE request message to the PACS archive requesting image storage, and the PACS archive would respond with a C-STORE response message to let the sender know, yes, I've stored that image, send the next one. So Here's a visual representation of that. You have the CT scanner here, and it's sending a store SOP request with an image to store a newly acquired image, and then it responds, hey, yes, I've got your images and I've stored them. The verification SOP class. This is the most unique SOP class because it doesn't have a data object component. It only has a DICOM service. The verification SOP class works like a standard ping, but it also includes DICOM connectivity. Where a standard network ping will tell you if a device is on the network, the verification SOP class will tell you if a device is on the network and if that device understands DICOM. The IOD for the verification SOP class equals, there isn't one. There is no data object. It's the only SOP class that does not have a data object. That sounds like a good test question. What is the only SOP class that doesn't have a data object? The verification SOP class. The DIMSE service for the SOP class is C-STORE. In fact, the UID for the C-STORE service and for the verification SOP class is the same. So for the service C-STORE, you have 1.2.840.10,008.1.1, and you have the verification UID, which is the verification SOP class UID, 1.2.840.10,008.1.1. And when you think about it, the only thing the verification SOP class does is trigger a C-STORE. It makes sense that they have the same UID. Hopefully that makes sense to you. It's very clear to me. Hopefully you get it too. Thank you for watching.